Hello, Alan. All right. Anyway, what I want to do is I want to spend a little time with the book, and everybody's reading the book. Is that right? And if we do have a test, we're talking about next week, probably on maybe Thursday. I'll have to look at the calendar and all that, but that would be a week from Thursday. Today's only Tuesday, right? So really you have a lot of time if you want to. A lot of time to do your homework. We've actually done quite a bit so far. Now, we actually have more than you think to do. All right, I'm going to show you this page here again. And if you were to read that page again, okay, you are right. I bet I have a clicker over here. Oh, I didn't pause it. Okay. Now we have to wait a little bit. Anyway, I'm on page 1004. How many times you hear a class say, turn to page 1004, and it's not church. In the church, sometimes you have to turn to, isn't that funny how the pastor does that? Everybody turn to page 85. Yeah, like everybody's Bible's different. That's why it's a joke. That's it. Okay. All right. But anyway, 1004. I want to show you. I did build another model for you, so I thought I want to show it to you. Are you ready? You're getting there. If you were to read this page, and you like science anyway, it is kind of interesting how they talk about the hybrid sp3 bond, meaning the four valence electrons are kind of like not really s orbitals, not really p, but they're kind of like sp hybrids. They're kind of in betweeners. You get that? And they overlap each other a little bit. And so, for example, if I were to make hexane, and the model kit company put these holes at the right angles. That's what makes them so good. And if I were to make hexane, it could look like this. See, it's not really flat, is it? The book makes it look like it's flat, but it has to pucker a little bit because the bonds are overlapping. You just can't. I just got to get a little more distance from you. And so they found out that about 99% of all the cyclohexane that they've ever discovered was this type right here. Now, I don't know if you can see this or not. Imagine these four right here. They're kind of flat, right? You see how one of them sticks up and one of them sticks down? That's called the chair. So, it's too salty. So anyway, that's kind of like the chair. I can't bend his butt, sorry. I need a G.I. Joe or something like that. But he's a straight chain. He's not a bent. Anyway, this is called the chair model, and I guess because you can put your head here, and somebody decided to call it chair, and then I'm going to bend the other way. Now watch. Okay, but then I also could bend it this way. See that? And that's why they call it the boat. And the theory is that the electrons here and electrons here would interact and tend. That's why only 1% of them are in this kind of a configuration, you know. And so only 1% are in the boat model. And boy, when I was in college, I remember seeing the boat, the chair. I had never built models. I didn't know what the heck they were talking about. It was just a picture in a book. And the pictures weren't that good either. They were just like plain old line drawings. I just want to show it to you, okay? All right. So what angle do you think these carbon atoms are at in a hexagon? And I know that you guys are used to doing this because I used to do that for a long, long time. You said, oh, wait, what's that equation in geometry for the interior angle of a polygon? And, oh, they'll never remember that. You're right. You won't. So let's see another way of doing it. Ready? If I start here, how many triangles can I make out of a hexagon? Don't go there. That won't work. Oh, that'll work. There's a triangle. Oh. There's another one. So how many triangles? And each triangle has 180 degrees, which is how much? You're going to multiply. Okay, so the total is 720. And how many angles are in here? So what is it? 720 divided by 6? So what is it? Uh-oh. What's 720 divided by 6?
120.
Okay, thank you. So anyway, the angle is somewhere around 120 degrees. Get that? And so if you don't want to remember that thing in geometry, just think about how many triangles can you make. See, that's how you do it. All right. Again, that's probably that's a little bit theoretical type of a page. I want to get back to these over here. When we were starting to look at alkenes, okay? Now you guys you did a whole bunch of alkane isomers, didn't you? Now I'm not going to get into huge numbers. The numbers of isomers are going to start getting bigger, and I'm not going to do that. I think 18 is plenty for somebody to come up with. You get that? So I'm not going to ask you to come up with any more than that before. As a matter of fact, it's going to be less. But something strange happens when I start putting a double bond in something. And so here is 1, 2, 3, 4. There's butene, isn't that right? Well, then what are you called? I'm butene. No, I'm butene. No, I'm butene. And what's the difference there? Aren't they both the same? Aren't those identical? Come on. Aren't they identical? And so this kind of an isomer is called a cis and trans isomer. And it doesn't happen unless you have a double bond. You got that? And the double bond has to be not at the end. It can't be between 1 and 2. You see that? It has to be inside. And so anytime you have a double bond that's inside, I don't mean you can't have it here, but if it's inside here, you could have put, here's the double bond, so let's draw a line right there. These two carbons could be on the same side of the double bond, or up here, or you could say on the two hydrogens are on the same here, or you could do this. You could draw a line and say one of the carbons are up here and one of the carbons down here. Now, they actually do have different properties, and so also, how do you name alkenes? Let's try that again. It's the longest parent chain that includes the double bond, and double bond takes priority. The double bond will make all the numbering happen. You see that? I'm the boss. The double bond says, I'll tell you what the number of the carbon. So if we look over here, 1, 2, 3, 4, and so this bond is between number 2 and 3, and organic chemists like to use the smallest number, so what are they going to call this guy? 2-butene. Now, what is this one called? Can everybody see? What's this one called? 1, 2, 3, 4. Isn't this also 2-butene? Okay, so which one is cis and which one is trans? And trans always means to go across, doesn't it? So I always think of this, hey, you're on the same side down here. I didn't cross a double bond. I just went over here, right? That's cis, and here's trans. Okay. All right, so let's try one. How would you name this guy right here? How would you name this structure right there? And this is the stick structure of it. So, well, it's cyclo what? Hexane? Cyclohexene. What number? What number? And again, this is what I like about organic chemists. It's like, wait, is there just one double bond there? Yeah. Well, do you really want me to say one cyclohexene? I'm not going to do it. If I say cyclohexene, then it's any of those, right? It's there. I don't have to say one. Isn't that right? Now, if you put another one, I do have to tell you. Right? Okay, so, all right. What about, well, don't look. It's hard for you not to look.
Wait,
so they wouldn't put a 1 here because if you only have one double, if it's cyclohexene, I know you have one double bond. Because, yeah, and 1 is anywhere you want. I mean, 1 is here. Okay, I'll call it, if you want to put 1, but they'll never put 1 because it's not necessary. If I put another double bond, let's take a look at this one right here. This one's interesting because I have a double bond and I have a branch. Now I got to be careful doing it. Who takes precedence in the numbering? The branch or the double bond? The double bond. So take a look at this guy. Ready? Here's, if I start here and go this way, 1, 2, 3, 4, 5, and so what? Would I say 5? Or what's the lowest number? What if I go this way? 1, 2, 3, 4, 5. Everybody see that? If I number it that way, then a double bond has the smallest number, doesn't it? So what would, don't act like you don't have a branch. What would you call it without the branch?
Say that again.
Without the branch, what would you call it? Everybody's gonna say cyclo, right? Isn't it cyclo what? Pentene. Okay, so cyclopentene, that's a good. But now, because of the branch here, I got to tell you where the branch is compared to the double bond, don't I? So we're going to call it 1 cyclopentene. Is that right? Yes, no?
No.
No? Okay, 1. No, why not 1?
Because it's still going to be in the ring structure. It doesn't matter where you put it.
Okay. Okay, now, but cyclo, see the 1 there? I need to tell you that it's 1 cyclopentene. Why? Because if I don't put a 1 there, I won't know where this guy is. I understand. You're saying because I put a 4 there, it kind of tells me where it's at?
Isn't that the L to methyl?
Oh, I see. Oh, I think you're right. Oh, I see. The 4 locks it in. The 4 says wherever that double bond is, I'm 4 away from that. Is that right?
Oh, I was just saying 4 is where the...
No, you're right. You're right. I made a mistake. That doesn't say 1. So I guess I wouldn't have say 1 cyclopentene because by putting a 4 here, if I'm 4 away from that, right?
I was just thinking that the 4 is the number, if you're going that direction, the 4 is where the methyl chain is attached.
Oh, by the way, let me ask you, I'm glad you brought this up. I can't go this way and say the branch is on number 3. Why not?
Because that's a 4-chain carbon instead of 5. And there's no double.
Wait, say it again?
Well, if you do that...
If I go this way, I did not include the double bond, did I?
Yeah.
So it has to include the double bond when I go around. And what if I start from over here? Now watch. 1, 2, wait a minute. 1, 2, 3, 4. Let's go the other way. 1, 2, 3, 4. Either way, it's going to be 4. The branch is on number 4. You get that? So I have to include the double bond when I start numbering it. All right. What do you think? All right, let's try another one. Hey, you're doing a great job. I know that it's the last period of the day, and I have no idea how much stuff your other teachers had you do today. I have no idea. Sorry. All right, let's try it. And I'm going to try to do this without looking at the answer. Can you do that? Think you can do it? All right. If you have a piece of paper, see if you could write down what you think this would be. And this is the hardest one I've given you since we started. This is the hardest one I've given you since we started. The longest parent chain that includes the double bond. Does everybody see that? And you want to give the double bond the lowest number you can give it. This is definitely the hardest one I've given you to name so far. Now, even though I use different colors ink, did everybody see that the longest parent chain that includes the double bond would be 1, 2, 3, 4, 5, 6? Everybody got that? If I go the other way, now the double bond is between carbon 2 and 3, right? So that's going to be called 2. If I go the other way, 1, 2, 3, 4, 5, it'd be called 4. So I'm not going to call it 4 because 2 is smaller. So there you go. 1, 2, 3, 4, 5, 6. All right, so what are we going to call it? Hex. The last thing on my mouth is going to be what? Hexene. Now, which hexene? 1, 2, 3. Between 2 and 3, the small 2 hexene. Everybody got that? Got any branches? Now remember, the double bond has already locked the numbers in. Don't you get it? The double bond takes precedence, so I'm locking the numbers in. 1, 2, 3, 4. I know if you went this way, the branch would be on number 3, but who takes precedence here is the double bond, right? So now what are you gonna call it? 4-methyl. 2-hexene. You're close. You're close. You're really close. Remember, when you have a double bond in the middle here, not on the ends, now you got to watch out for cis and trans isomers. So what do you think? Trans? Okay, let's see what the author said. Author said the final answer is, where are you? There you go. 4-methyl. It is 2-hexene, but it's trans, isn't it? 4-methyl. Trans 2-hexene. Woo! That was a hard one. All right, let's do one more. And then I'll move on to something else. How about this one right here? Don't look at the answer. Look up here. Oh, don't look. Don't look. The longest parent chain that includes the double bond. 1. This is a triple bond. Triple bond. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's okay. It's okay. You can go either way. You can go either way. What's the last thing out of your mouth? Heptine. But wait, which heptine? Tell me where that triple bond is. Well, if I go this way, 1, 2, 3, 4, 5, I'd be 4. If I go this way, 1, 2, 3, 4. It's between number 3 and 4, right? What are you going to call it? 3 heptine. Now, if you call this the parent chain, I'm okay with that. Now, do we have a branch?
Yes.
All right, so what do you think? Where's the branch at? Now, you might say 1, 2, the branch is on number 3. No, your double bond already locked in the numbering system. Your triple bond locked in the numbering system, didn't it? 1, 2, 3, and 4. So this is 3 heptine. So this has to be the 4th carbon, and this has to be number 5. 5-ethyl, 3 heptine. Whew. Now, almost all the questions on your test next week, next Thursday, for the naming ones, almost every one of them is multiple choice. You get that? So I think that'll make it a little easier. I do have one section, just like you did the whiteboarding here, I might have you draw and name isomers of octane. I might do that. and now you should be a little faster at that by now. Yes, EJ.
I've noticed that for these last 2 examples, these carbons that are going from left to right, they don't show the bonds between them. Would you like us to write bars like that, or do you want us to keep them?
Wait, I lost you on that. What do you mean writing left to right?
One will say, like, for example, B, it says CH3, CH2. There's no bond between them, like the triple carbon. Or like the triple
Are you on this one?
Any of them.
Oh.
Okay, look at B, right? So the ones that are going down, there's a line between them to indicate a bond. But for the ones that
Oh, I see. I see what you're saying. I see what you're saying. I think what happened is if you're typing this on a computer, if I type left to right, then I know they're right next to each other. You see that? They're in a line.
Okay.
But if I type here and don't put a little bar, and I type here, you'll say, hey, there's a floating methyl group. So I had to have a bar here to show you that it was really attached. That's a good question. No one's ever asked me that question. That's
So
interesting.
you'd like us
See, what would this look like without these 2 little bars? Whoa, floating methyl. And you couldn't tell they were attached, could you? But if you go left to right, then they're attached. That's a great question. No one's ever asked me.
What do you prefer for like a test? Or
Well, if I just say the carbon backbone, you're gonna make a little line between them anyway, aren't you?
okay.
Wow, that's a great question. I'm surprised nobody ever asked me that before. All right, what I'd like to do is show you 2 more things. Let's take a look at this one. And I'm not an organic chemist. I'm not. I've already said this several times. But somebody over the long history, over 100 years of organic chemistry, over 100 years, I didn't know that iron 3 chloride could be a catalyst. I didn't know that, but somebody did. somebody figured out if you take benzene and put it with chlorine, we don't know, if maybe nothing will happen. Benzene's kind of stable. It's hard to get it to react, but it seems like if you put this guy here, for whatever reason, that catalyst will say, boom, boom. And what will happen is, you know what used to be there, a hydrogen atom, and it'll go boom, boom. It'll kick the hydrogen out and replace it with a chlorine and give off HCl. You know that? Now, I didn't discover that. And so, what are you going to call this guy? How come I don't use a number for that? There's only one chlorine, right? It's turned around. One chlorobenzene. Oh, two. I mean three. No. It's just chlorobenzene. Now, I didn't do this either, but somebody figured this out. All right. What if I were to take nitric acid and sulfuric acid? Now, one thing I did learn in chemistry, these combination right here. This right here is a dehydrator. He loves to take water out of things. I do know that. Like one time in high school, I don't think they did as much safety. I don't think they talked about safety as much as they used to. But I remember I got some concentrated sulfuric acid on my hand, more than once. It just looked like water, and I watched it, and whoa! And then it started burning, and what it was doing was irritating my nerves. It felt like it was on fire. And even if I washed it off, it still felt like it was on fire because the nerves were sending a signal to my brain. You hurt me. Okay? Well, a few days later, that spot turned brown and black. I was like, what the heck is that? And by the way, what happened is it took every bit of water out of my skin. It dehydrated every cell that was right there and essentially killed it. And it took a while for them to turn black. But it's a dehydrating agent. So I know that this is a dehydrator, and that's probably where it ripped an H and an OH off of somewhere.
Would that be considered a catalyst?
Now, so there's your catalyst, and this is the reactant. And what they're trying to do here, instead of putting a chlorine on there, they're trying to put a nitro group, nitrobenzene. And then, again, I didn't, this would be called, you know what this is called? What's this called? What would be a good name for that? If that had been a hydrogen, that would have been methane. What do you think a good name of that right there? Uh-oh. No guesses? Just say a guess. So, what?
Chloromethane?
Yes, chloromethane. Oh, okay. I didn't discover that either. And look, aluminum chloride, who discovers this kind of stuff? But somebody did, and every organic chemist might know that. I'm trying to make something, I really need to attach a methyl group to a benzene ring. Oh, that's what you do. You do that. Hey, it worked. I just want to show you that because those are things that organic chemistry do that wasn't my favorite thing to learn. Step 1, step 2, step 3, because they want you to memorize these different mechanisms. But I will tell you what I did like this. Let's try to name this, okay? Let's name this. And what we see here is it's benzene, I get it, and it's dichlorobenzene. Is that right? Everybody get that? Would you name it dichloro? Now, do I need to put numbers or not? The question always is, could you make dichlorobenzene another way? Yes, then you better tell me which way you made it. So what do you think we're going to do here? This is an easy one. This is kind of an easy one, but what do you think you're going to name this? Where are you going to start numbering the carbons? I could start here, couldn't I? What if I went counterclockwise? 1, 2, 3, 4, 5, 6. 1, 6 dichlor. I could do 1, 6, couldn't I? What else could I do? 1, 2. Oh, that's a smaller set of numbers, isn't it? So what's the final answer? 1, 2 dichlorobenzene. Now here's something that I remember. It was 45 years ago, and I still remember them talking. I didn't know what they were really talking about too much. I knew a little bit. But here's, if you met a real organic chemist, they have these things. One of them's called ortho meta para. Huh, what's that? What's that? That's some kind of a shortcut. And what do they mean? What do they mean by ortho? What's ortho? You know what ortho means? All right. Okay. In this case, they said ortho means two adjacent carbon atoms. See that? So these guys are ortho dichlorobenzene. So here's another one. Ready? 1,2 dibromobenzene. But what's another way to say 1,2? And it's ortho. Now, I don't know if I like that prefix myself. Yes.
Doesn't, if it gives you, if they're adjacent, does it really matter the numbering system? Because,
Well, in this case, for a benzene ring, here's what you have. I'm either here and you're here.
yeah,
I'm here and you're here. Or I'm here and you're there.
right.
Because if you say you're here and I'm there, I already did that one. That's a repeat. If you say
Yeah.
I'm here and you're, that's a repeat. So there's only 3 choices.
I guess I'm saying, like, if we have ortho, meta, and para, then we know that if it's ortho, it's gonna be adjacent, so it doesn't matter which side you go on. It's gonna
If I put this over here, it's still ortho.
So, do we need the numbering system for those ones that were given
Right.
their para?
Notice that when they used the word ortho, they left the numbers out, didn't they?
Okay,
If you leave the numbers out and said ortho, and you could do maybe some kind of memory trick. And by the way, I know meta in the middle, right? Meta means in the middle anyway, doesn't it? Where's meta? Who's Latin people? You are. Isn't meta mean in the middle? Meta? No, or okay. Meso? Does meso mean middle? Media? Okay, right. So anyway, I know that meta is in the middle, so that's an easy one for me. Okay, now, and then para, I don't have a good memory trick, but para is going to be like on the other side. I'm not sure how you want to memorize this, but ready? Ortho, meta, para.
if we gave you just the ortho, meta, para on a test,
You wouldn't have to have numbers.
okay,
If you want to give me numbers, you'll say 1, 2, 1, 3, 1, 4. Yes.
If we use numbers, we wouldn't have to use the suffix.
Wait, Calvin, say it again.
If we use the numbers, we wouldn't have to use the suffix.
So here's what's happening, okay? If I ask you to name it, you can name it either way. What if it's a multiple choice question from the author? Which of the following is ortho dichlorobenzene? Then you have to know what ortho means. Yes.
So I guess, like benzene with this naming system is a lot more important to like cyclohexane.
You know, I don't know why you couldn't use this with cyclohexane.
I'm just wondering, with cyclohexane, you have 2 bonds on the outside of the ring for each carbon atom.
No, you don't mean. Oh, you mean 2 hydrogen atoms?
Well, yeah, I mean, if you replace.
Oh, I see what you're saying. That's a great point. If I use this system with cyclohexane, I could replace both hydrogens with that. Then it would be like, what do I say then when I have both of them on the same carbon atom?
Yeah, would that be?
You know, maybe, I need to look this up. Maybe this is only used for a benzene ring. That's a good question because that would open up the floodgates for, am I going to say 1, 1? No. That's a good question. And you're right, I couldn't really use ortho-para. I couldn't use that with cyclohexane. That's a great insight. All right, let's go down here. And we'll be done as soon as you name these, okay? Here we go. Okay, let's name these. And you take a guess, and you said, oh, I'm getting pretty good at guessing these. And remember, most of the test, when you have to name something, it's going to be multiple choice, isn't it? So you can eliminate answers. All right, that's the next one. Well, what do you think about that one? This one right here.
toluene,
It is. Now, what else could you call it? Methylbenzene. What do you think about that? Do I need a number?
no.
Okay. Ding, 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 ding. Okay, let's do the next one. Whoa. Ooh. Ooh. All right. All right, take a guess. If you don't have your book open, this is good for you to guess.
1 nitric
Nitro, yes. Nitro's up there. And bromo.
Bromobenzene.
What's your numbers again?
1 nitro, 3 bromo.
Okay, let's take a look now. Wait, watch out now. Why in the world would they put bromo first? Oh, wait a minute, I'm sorry. You're right. It is nitrobenzene. They decided to call it nitrobenzene. Now again, that's one of those funny things I don't quite know is if I was in organic chemistry for 20 years, I'd know that, hey, I'm not gonna say 1 nitro, 3 bromo. I'm just going nitrobenzene. And it's got a bromine on it, so let me tell you where that's at. How about the next one? Ready? All right, in this case, they're going to call it toluene, so that takes care of that. Now, once I say toluene, then where are you at? 3-chloro, toluene. Okay, and the last ones, here we go. What about that guy? Whoa. Huh? Phenol, that's an OH, but I thought phenol had OH on it. Oh, phenol group. Ah, that's dumb. Phenol group means I'm attached to something else. Okay. All right, how about this one? Look at this. 4. Wow, look at this one. Phenol means that I have a phenol group attached. That's my branch. My branch is a phenol group. 2 phenylhexane? And that locks in the numbering system. 2 phenylhexane. Where's that chlorine at? Wow. Okay. And again, I know it sounds weird, and we only have a limited time here. Like I said, most of the things you're going to number are multiple choice. All right. Thank you very much.
Mr. Bean, in this case, is the phenol locks in.
This one, the way they drew it, it should have been, it's this one.
Yeah.
So I think what they should have meant is that this is going to be attached to something else.
Okay, so for this one, the phenol locked in because you used.
Yes. So
used
it took
4-chloro.
precedence over the chlorine.
Okay.
Now, that's another good question. Hey, who says phenol is better than ethyl? You know, somebody did. And I would never ask you that.
Okay.
I'm not an organic chemist, so, but this must be a pretty important thing because it's almost always takes precedence over all these other guys.
Phenol
But,
does.
yeah,
Okay.
it's big because the benzene ring, isn't it?
Okay.
So
Thank you.
once he locks it in at number 2, then you have to call me number 4.
Gotcha. Thank you.
Something I wanted to ask you about.
That was a good question because even though I was thinking about cyclohexane after you said it, I said, well, I guess they could use it. And I thought, yeah, great insight because wait, I don't have just one thing I can substitute. I can substitute 2 things.
Yeah.
That was great.
One thing I wanted to ask you about.
Cis and trans.
hmm?
Cis and trans.
Well, no. It has to do with the other day we were talking about how this bond can't like spin.
That's what they say. They say that it's tight enough that it won't twist. You know how when we had single bonds,
Yeah.
you could twist a bond,
Yeah.
and they're saying no, it's not going to happen.
What I don't really understand is
You
the
understand?
electrons that are forming this bond.
So, two here, one of yours, one of mine, one of yours, one of mine. That's 4 electrons.
But the like the electrons over here, like what causes it to spin, right, is these
Oh.
electrons are moving over.
It seems like when they're sharing one pair of electrons, that allows this thing to actually rotate. I'm gonna rotate the bond.
Well, but like when you think about it, the atom isn't like a solid block like this. You have a field of
Right.
valence electrons, and you have a nucleus inside.
Right. So let's say we have hydrogens here. If I were to rotate this, you'd see the hydrogens rotate around. Like they're saying the hydrogens would actually rotate around like this. So
Right.
they're sticking out like this. They would be allowed to do that.
So it's not the nucleus spinning. It's,
No.
Okay. So why does that change when there's a double bond right here?
Okay, now, this says that even though we share in a pair of electrons, that doesn't keep me from spinning around this, to turn around this bond. But here, we're sharing 2 pair of electrons, and that's
some
very
reason.
theoretical. I guess I don't know the exact answer, but theoretically it says, you try to twist on me, then that's going to break, it's going to do something to my double, like, Wait a minute, you
Yeah.
can't start spinning.
I just don't really, cause like, obviously that logic works with the model, but
Yeah.
with the actual thing, it's this.
I'm sure they're gonna say something about the double bond,
Just
it holds them
repelling.
together tighter, and triple bond even
Oh,
more.
yeah.
The triple bond even more.
closer
Maybe this
together.
thing even does this a little bit, but I bet triple bond, it probably even doesn't do it at all.
So it has to do with the atoms being closer together. In the double
Now that's
bond.
something else, I could look that up. You can look up what they call carbon-carbon bond distances. And I'll give you credit, okay? Look up single bond, carbon-carbon, single bond distance, double bond, triple bond, and let's find out.
Okay.
And I believe they're gonna be closer,
Okay.
so more attractive, less likely to let you move.
I'll try to look at that.
All right,
Mr. Feeney, what would be a good time tomorrow for me to come in and check the, the atom naming worksheet with you? That's on the back of the packet that we have.
wait,
With the,
what's it called?
I don't,
On the back?
yes, not on this sheet, but it's the first packet that you gave us, where we learned,
You mean in organic chemistry 1?
yes.
Oh, are you talking about the artificial flavors and things?
Yeah, with the
Oh, yeah,
chocolate.
'cause you
and
were
the-
doing-
Yes.
That's gonna fall.
Yeah, so
That's gonna fall.
I was gonna
That's gonna
check
fall.
the, oh,
Yeah, so, it was starting to tilt. Okay, now, you were doing an extra credit, I thought,
yes.
and, if you can, if you can give it to me, I'll just take the time and I'll just look at one and we can look together if you want. I have 3 students come in today, but, I have I have tomorrow morning, I have tomorrow at lunch, but I have a meeting after school on Wednesdays.
Okay, because I wanted to type it up for you so you
Okay.
can have it as an
If
answer
you
sheet.
if you let me look at it in the morning, I can probably in 5 minutes tell you, hey, that looks good, that looks good, and yeah, even if we had to change it, I could probably look at a lot of them in 10 minutes.
Okay,
That'd be good. Tomorrow morning would be good, or tomorrow at lunch.
okay.
All right. Oh, I don't know why I didn't turn this off.